Hello, everyone, and welcome. Thank you all so much for joining today. So today is part one of our journey to the cloud, IBM Cloud Deployment 4 Ways. So today we will be doing a deep dive into all things cloud deployment. What does that mean when we're talking about deployment? What are different deployment models? What are IBM offerings for different various types of cloud and hybrid deployments? And next week we will follow that up with a hands-on workshop where we will show you how to deploy to all of these different deployment models using IBM Cloud technologies and offerings. So again, thank you all for joining us today on this lovely workshop Wednesday. Just move my computer over a bit so I can see. Okay. So if this is your first event, welcome. So glad to have you here. If you've joined previous sessions before, you know the drill. So no pressure, but if you would like to get to know your fellow techies that have joined here today, feel free to share in the chat your name and pronouns, which company, your title and company, or maybe a program you're currently doing, whether it's with a university or boot camp or self-learning, where you're from, or where you're joining from while you're working from home, something you love, and a quirk, so something that's uniquely weird or different about you. So I'm going to go over a few pieces of housekeeping while you all get situated and get acquainted in the chat, and then I'll be introducing myself as well as our other speaker that we have here today. So if you scroll to the very top of the chat, to your right, at the very top, you will see that I have posted all of the links for all of the resources here for you. I have the very first link here is the slides. So everything we're covering today, you will be able to access with the link to the slides. Feel free to comment, ask questions. The commenting is turned on all the slides. So if anything's not clear, or you'd like to add something, or maybe you'd like to see something in the V2 of this workshop, feel free to add comments. I also have here for you all, so the link that you joined with today, that is the same link that if you would like to watch or share the live stream recording, this is the Crowdcast link. Again, this is the same link that you joined with today. So if you go to your URL right now, this is the URL that we're all currently using for the live stream. If you're joining on YouTube and Twitch and other platforms, you'll be able to access the recording at the Crowdcast link as well as my YouTube channel and a few other places. So don't worry, lots of options for you. The next link I have here is the IBM Cloud sign-up link. So if you would like to follow along and check out some of these things for yourself, you will need an IBM Cloud account. We do have an IBM Cloud free tier account. It's our IBM Cloud Lite account. It is completely free. You won't start getting charges at any point in time. It's free until you use up all your services, at which point you can delete some and spin up some new ones. And we have over 40 light tier services as well. So if you want to create machine learning models or build a chat bot or do anything fun like that, you can do that all for free with our light tier. So if you're new, welcome. Let me introduce myself for you. My name is Jenna. I am a cloud developer advocate with IBM. My pronouns are she, her. I am currently joining from Detroit, which is where I'm from, although I work with the New York City advocacy team. Something I love are my dogs. I have Yorkies. Luckily, hopefully they'll be quiet this time. Sometimes they get loose and they like to scratch on my door, but they seem to be wrangled at the moment. And then a quark. So I always go with the same thing. If it ain't broke, don't fix it. So I have an obsession for tuna melts and tuna salad sandwiches. If I could eat them every day, not get mercury poisoning, I definitely would. And I basically judge an entire restaurant and all of the food on their menu based on how much love and effort they put into a tuna melt. So if you know any good places, feel free to share. I will definitely check it out. I would like to pass over to our speaker today, who's going to be talking to you a little bit about Call for Code and doing a little bit of a deep dive with us a little bit later. So Upkar, why don't you go ahead and introduce yourself?
Yeah, thanks, Jenna. I can still hear an echo of my own voice, but I'm going to try and work through this as long as you can hear me.
Yep, I can hear you. I don't hear the echo at all.
Okay, awesome. So I'm hoping others also don't hear the echo. So hi everyone, my name is Upkar. I work with the Call for Code team. I'm a developer advocate. I work with a whole bunch of different technologies, including I think somebody else also hears an echo.
Oh.
All right, let's do this. I'm going to try and fix this on my side. Thank you, everybody. Jenna, I think you're doing the first part of the presentation. I'm going to try and log back in and see if that fixes the echo. But
Okay.
nice to meet everybody, even with the echo.
Okay, cool. So Upkar will join us in a little bit. So it looks like we had a comment in the chat, any meetup in NYC. So just quickly for reference, IBM Developer, we have city locations in the Bay Area, Austin, New York City, Raleigh. We have advocates globally all over the place. We've been doing everything virtually. However, once we're able to safely do things in person again, we generally tend to, in the US, do events in a lot of places, even places like Chicago and Detroit and things like that. But our busiest areas are usually the Bay Area, New York City, and Austin. So I'm going to go ahead and give you an intro. So before we get started, one of the things I just wanted to mention is that we have our Call for Code challenge going on. I'm going to give you just a brief intro. Upkar's going to talk to you a bit more about that a little later on, go over some examples of projects and winners from last year, some use cases for different deployment models. But Call for Code is our our global Tech for Good challenge. It started in 2018. Since then, we've had over 400,000 innovators participate, creating projects and innovative solutions. I'll show you those on the next slide. And contributing from over 170 nations around the world. And we've had over 15,000 apps created for different humanitarian issues, which change year to year. Since 2018, which is from again, anyone globally can participate in Call for Code. So our challenge for 2021, we have 3 global focus areas. So according to the UN, impacts of climate change are global, and they're reaching an unprecedented scale. So without doing anything today, the future is looking more and more difficult and costly as we move forward. That being said, we have created the 2021 Global Challenge into 3 sub-themes. So this year we have clean water and sanitation, zero hunger, and responsible production and green consumption. So a lot of solutions that we see are, solutions that can be implemented globally, right? Everyone in the world doesn't have a smartphone. A lot of people don't have access to technology. So how can you build impactful and sustainable solutions that can be deployed and implemented globally? So this year, again, focus areas: clean water and sanitation, zero hunger, and responsible production and green consumption. So just a few reasons of why join Call for Code. I'm a big proponent of skill building. You can learn about enterprise hybrid cloud technologies, develop skills and enhance your professional career, build solutions that can have a positive impact on the rest of the world. The Call for Code community is a really great community of developers that are really focused on solving societal problems and making an impact, really focused on creating tech for good. And it's not like your average hackathon, so you have a lot of time. Call for Code deadline is the end of July for this year to submit your solution. But we started earlier in the beginning of the year, so you really have a good amount of time to work on your solution, put a presentation together, do research. We have Call for Code starter kits that I would be happy to share with you as well. Upkar is going to be in the Call for Code Slack workspace, hanging out. If you wanna say hi, Upkar, maybe you can share the URL for the Call for Code Slack workspace for anybody that wants to join. And the last but not least reason for joining Call for Code. So there's a $200,000 grand prize. So the winner of Call for Code is going to win $200,000 and support from IBM and its partners to help set up the winning team from concept to company, right? So if your idea is the winning idea, IBM, not only do you get a prize, but you'll be working with IBM, where we'll support you in developing out and scaling out your concept into a scalable product that you can then start a company and start implementing the solution if you would so like to. So we'll take a look at some examples of that a little further. Cool. So Upkar just posted the Call for Code Slack workspace if you would like to join. And we have mentors and technical support and everything available in there as well. So if you ever have any questions, I worked on the Zero Hunger starter kit this year. We're available to answer any questions and help out. One thing I like to always share, I won't spend too much time on these, but one thing that's really fantastic that I personally have spent time on, especially when I first joined IBM, was our IBM developer skills and cloud essentials, all of our IBM credentials. These are completely free to you at no cost. It's not one of those things where you take the course, then you have to pay for a certification. The whole thing is free, and we have everything from machine learning to chatbots to Apache, Kafka, and everything you can think of. And they are absolutely free. And I like to personally put them on my LinkedIn. It's a good way to showcase, what skills I have technically and foundations with. Highly recommend. So these are just a few. The first one is the IBM Cloud Essentials badge. I also have the Cloud Application Development Essentials badge. So this is kind of like Cloud Development Essentials. And then this one's fun. So this is going to be like your cloud native applied cloud development badge. So if you're looking to, get your hands dirty and start building cloud native applications, this is the badge for you. The first two are a nice foundation to get started with the with cloud application development. Another one that is a newer-ish badge is this Cloud Core badge. It's kind of really getting deep dive into some of the things we're going to talk about today, different deployment models, hybrid cloud deployment models, what the differences are, what are some offerings associated with those. And then the last one, we have a Docker Essentials badge. So if you're learning to build your first container image, deploy your first container using Docker Hub, we have a badge for that as well. So let's go ahead and get started. Let me just pull up where are we at here? Here we go. Okay. So what we're going to start with is cloud deployment 4 ways, right? So there's kind of 4 main cloud deployment models that we're going to focus on today. Kind of 4 main computing options. So first we have IaaS, which is also infrastructure, short for infrastructure as a service. So this is going to leverage existing languages and tools. These are like think of like your VMs, your virtual machines. Then we have our CaaS, or container as a service. Think like your Kubernetes containers, right? So this is going to give you kind of maximum portability. Then we have our PaaS, which is a mix of going to give you a mix of developer speed and control, right? It's going to give you some control, but take care of a lot of things for you. So this is our platform as a service compute option. And the last one is going to be our serverless, which if you're dabbling into serverless, it's also known as function as a service. And this is really going to give you the most maximum developer speed. So it's going to take care of all of that, those infrastructure pieces for you, so you can really just focus on development. So just for example, we're going to talk about a little bit more, but when we're talking about IaaS, infrastructure as a service, we're talking about things like VMs. When we're talking about CaaS, or container as a service, we're talking about things like Kubernetes. When we're talking about PaaS, platform as a service, we're talking about things like Cloud Foundry or IBM's Kubernetes as a service. And then when we're talking about FaaS, or function as a service, otherwise known as serverless, we're talking about things like Code Engine or IBM Cloudant. Okay. Oops. Okay. So the first one, so infrastructure as a service. I'm going to do like a brief overview just to be, get you all familiar with what these are, what are the deployment models. We're going to explore what IBM offerings are associated with them, and then what are the benefits, right? So you can see like, oh, these are the things that I'm looking for in my deployment model. This is going to be probably a better option for me. So starting with infrastructure as a service. So infrastructure as a service is a type of cloud computing. It allows you to allocate your compute, network, storage, and security resources on demand. So again, this is like your virtual machines. So the IBM Cloud approach to IaaS is going to let you scale and shrink resources as they're needed globally in more than 60 of our data centers. You'll get access to the full stack of compute down to bare metal. You'll get a lot more control, and you'll be able to customize hardware to your exact specifications and meet really precise demands of your workload. There we go. So when we're talking about IaaS, some IBM products and offerings. So what we're talking about here is our virtual private cloud. So that's our IBM Cloud Virtual Server for Virtual Private Cloud. That's VPC, Virtual Private Cloud. And then we also have our classic infrastructure, which is our bare metal and virtual servers. So these IBM offerings, are compute, containers, databases, networking, security, and storage. Yeah. So some pros to infrastructure as a service. So, oops. Oh, there we go. Okay. IaaS allows you to accelerate performance. So you can deploy an IaaS bare metal server, a virtual server, or both in just a few minutes. You can integrate IaaS with your systems. So you're able to take advantage of IBM services being integrated to optimize performance. You can employ enterprise-grade hardware, so you're able to select from more than bare metal and virtual, including SAP-certified infrastructure. And then you can also extend your on-premises data centers. So you can create, deploy, and manage servers on their own or in a hybrid cloud environment. So what's an IaaS typical use case look like? So typical use cases for IaaS it represents more general purpose compute resources, and so it's able to support use cases of pretty much any type. So today, IaaS is most commonly used for dev and test environments, customer-facing websites and web applications, data storage, analytics and data warehousing workloads, and backup and recovery, particularly for on-premises workloads. IaaS is also a good fit for deploying and running common business software and applications such as SAP. While IaaS is capable of supporting a pretty diverse array of workloads, as we'll see as we kind of explore this further, there are emerging compute models that might be better positioned to support certain types of workloads or application architectures such as microservices. So the next thing we're going to look at, so the next deployment model we're going to look at is CaaS. So this is our containers as a service. So think Kubernetes. So when we're talking about CaaS, containers are ideal for app modernization and hybrid multi-cloud scenarios because they're really lightweight and portable. And with container services from IBM, they're built on open source technologies like Kubernetes. So you're able to facilitate and accelerate your cloud services. You can use continuous integration and continuous delivery tools to build and deploy your containerized applications in the cloud. You can orchestrate your containers with a managed Red Hat OpenShift or IBM Cloud Kubernetes service, and you can address most of your transformation needs with containerized IBM middleware and open source components found in our IBM Cloud Pak solutions. So we'll look at in just a second our IBM products and offerings for CaaS are things like IBM Cloud Paks, and we have IBM Cloud Paks for a number of things that we'll touch on in just a second. One more thing to mention, we're going to talk about CaaS a little bit because it can be kind of an abstract topic. I want you to be able to put visuals with what we're talking about. But Red Hat and IBM were actually named the leader in multi-cloud container development. So We have a lot of solutions. We have a lot of different tailored solutions. So we'll kind of take a look at that, and then we'll take a look at some of these cloud packs as well. But to start, right, I'm throwing out a lot of words that might be new. You may be still on, well, what do we mean when we're talking about containers, right? So let's get all on the same page here, so we have kind of like a foundation of what's going on. So what is a container? So this is kind of I think a really nice graphic that illustrates virtualization versus containers, right? We just got done talking about virtual machines. Now we're moving on talking about containers. So a container is just a standard unit of software. It packages up the code and all of its dependencies so that your application can run quickly and reliably from one computing environment to another. So for instance, if you're working on a dev team and, one person on your team works on Linux, one person works on Windows 10, and one person works on a Mac. This allows you to develop your applications regardless of what computing environment or operating system you're running. Containers are available for both Linux and Windows-based applications, and containerized software will always run the same regardless of the infrastructure. So it doesn't matter what operating system you have, it will always run the same. And what's really nice is containers are going to isolate the software from its environment to ensure that it's working uniformly, despite differences, for instance, between development and staging. So as you can see here, all of these things are laying right on top of your host operating system. So it doesn't matter if this is Windows or Linux, they're all going to run uniformly. So we talked about containers. So what are we talking about when we're talking about container images? So a container image is an unchangeable static file that includes executable code that it can run an isolated process on IT infrastructures. So for instance, right, we just looked at containers. Now we're looking a little bit more closely at a container image. So our container image is a lightweight standalone executable package of software that includes everything that it needs to run an application. So that includes the code, the runtime, the system tools, system libraries, and settings. And as you can see here, we have these different layers, right? So we have our read-only and we have our read-write. So here we have our top layer here. So a container image becomes a container. Remember when we saw in the last image, a container image is going to become a container at runtime. And for instance, in the case of Docker containers, images become containers when they run on Docker Hub. Or for instance, we'll look at a little later when our container images are going to become containers running that executable code when we run them on Code Engine, for instance, which is our serverless offering. We'll take a quick look at. So for instance, every time we make changes or deploy a new version of our application, right, we have different layers here. And our most recent, our current container image, when executed, is going to become our container that we're of our application that we're running. So one thing I just want to introduce is when we're talking about container registries. So a container registry is a repository or collection of repositories used to store container images for Kubernetes, DevOps, and other container-based application development. So I just wanted to share, just so you're aware. For instance, you might be familiar with using Docker Hub, or if you've done some work with OpenShift, maybe you've used Quay. IBM has a container registry. It's called IBM Container Registry. We have public and private registries as well. So you can deploy any of your container images. You can deploy them to Code Engine, for instance, any of our Kubernetes, any of our offerings, directly from your container registry. So I just wanted to make you aware of what your options are. So I use container registry, I use Docker Hub, I use Quay for a number of workshops and things that I do. So the next thing we're going to talk about is containers. Oh, I'm sorry. I lost my place for a second. Thought I was losing my mind. Okay, so when we're talking about our IBM CaaS offerings, what we're referring to here that we're going to take a look at is our IBM Cloud Packs. So what's an IBM Cloud Pack? So an IBM Cloud Pack is a collection of offerings that we have bundled up, ready to go for you, for doing things like we have IBM Cloud Packs for data, business automation, Watson AI Ops, integration, network automation, and security. Let's see if I have. Let's see if I have this here. So some things that we have included and bundled together in our Cloud Packs. So we have things like logging and data analysis, security, integrations like machine learning and things like that. So these are pieces, services. They're really just IBM services that are all bundled together and ready to go depending on what your needs are, right? So if you need an application and Watson AI Ops or business automation or maybe security, it includes all of the pieces you need to build and deploy and scale a secure application with all of its enterprise ready with all of the pieces that you need. Looking back at containers as a whole, so enterprise clients from all different industries are seeing now the benefits of containers as a service and container technology. So using containers provides an increased efficiency and gives clients the ability to quickly deploy innovative solutions for app modernization and cloud native development with microservices. Containerization also helps clients release software faster, and it promotes portability between hybrid and multi-cloud environments. It reduces infrastructure, software licensing, and operating costs. So some of the benefits that clients see from container adoption is 50% better application performance, 45% improved software quality, and 45% better application portability. There we go. So some benefits, some pros of containers as a service, portability. So container as a service is portable, it's highly efficient and cost cutting, it's secure, it's fast, and it's smart scale. So when it comes to scaling, containers feature the ability for horizontal scaling. It allows users to incorporate multiple identical containers within the same cluster to scale out. So by using smart scaling and running only the containers that you need when you need them, you can really reduce your costs and boost your return on investment. And the last piece they got left off here for some reason, is streamline development. So containers as a service really have effective and efficient development pipelines. It's an advantage of any container-based infrastructure. So containers allow applications to work and run as if they're built locally. So the environment inconsistencies are completely eliminated. And removing local environment inconsistencies helps to streamline your testing and debugging. It also doubles for updating applications because it only requires the developer to take a few moments and modify the configuration file, and then you can generate new containers and delete the previous ones. Let me just see here. Okay. Here we go. So a container as a service typical use case, what does that look like? So I included a link in the slides as well, but we have an ExxonMobil use case. So the business challenge here was ExxonMobil needed expert design guidance and powerful cloud infrastructure to bring an idea for a smartphone app to fruition and provide a secure, streamlined user experience. So the results were that it drove down the operating costs with flexible IBM Cloud infrastructure. They were able to handle millions of downloads, drawing new and legacy customers to Exxon and mobile stations, and it allowed it to handle countless transactions, manage their transactions so that they were faster, safer, more secure, and more convenient. So I have there's quite a bit. It's a pretty long article, but like I said, I included it in the slide there. It's a little bit of a read, but I want to include it so that if you have a minute and are interested and want to look into it later, you can. So the next deployment model we're going to look at is platform as a service. So platform as a service, or PaaS, is a cloud computing model that provides customers a complete platform. So that includes the hardware, the software, and the infrastructure for developing, running, and managing applications without the cost, complexity, or inflexibility of building and maintaining that platform on premises. So platform as a service provider hosts everything. So IBM, for instance, the servers, networks, storage, operating system, software, and databases at IBM data centers. Customers use it all for a monthly fee based on usage and can purchase more resources on demand as they're needed. So in this way, PaaS is going to let the development teams build, test, deploy, maintain, update, and scale applications, and to get more innovative in response to changing market opportunities or threats. And they're able to do this much more quickly and for a lot less expensively than they could if they had to build out and manage their own on-premises platform. So what does this look like? So some IBM products and offerings are IBM Cloud Kubernetes service, IBM Cloud Foundry, and Red Hat OpenShift on IBM Cloud. Okay. So some benefits to platform as a service offerings. So some very specific advantages that you can realize from using platform as a service. First one is the faster time to market. So with PaaS, there's no need to purchase and install hardware and software that you need to use to build and maintain your application development platform. There's no need for development teams to wait while you do this. They can just get right to work, start development, and you simply tap into the cloud service providers platform as a service like IBM Cloud resources, and you can begin developing immediately. So as we saw, like IBM Cloud Foundry or Kubernetes service, you can tap into the IBM service platform as a service resources and begin developing right away. So another benefit is it's a less risky adoption of resources. So it's faster, easier, less risky adoption of a wider range of resources. So platform as a service platforms typically include access to a greater variety of choices up and down the application development stack. So that's from operating systems to middleware and databases and tools such as code libraries and app components. So for instance, Watson machine learning, Watson chatbots, log DNA for analytics, so that you can affordably and practically maintain these services on premises. It also lets you test new operating system languages and tools without any risk. So what that means is you don't have to invest in the infrastructure required to run any of them. It's an easy, cost-effective scalability. So if an application developed and hosted on premises, let's say you start getting a lot more traffic, right? And you're not quite sure how you're going to handle it. You'll need to purchase more computing, storage, and even network hardware to meet that demand, which you might not be able to do quickly enough, and it can be wasteful. So you typically purchase, since when you're purchasing things, these things as a business on your own, you typically are purchasing more than you need, which can result in waste. So with platform as a service, you can scale on demand by purchasing just the amount of additional capacity you need and no extra. The last thing is it really lowers costs. So because there's no infrastructure to build, your upfront costs are a lot lower. And costs are also lower and more predictable because most platform as a service providers charge customers based on usage. So for instance, if you were using Red Hat OpenShift on IBM Cloud, you are being charged based on your actual usage. There we go. So what does a typical platform as a service use case look like? So there's a lot of different use cases for PaaS, including popular application-based ones. So API development and management. So you can use PaaS to develop, run, manage, and secure your APIs and microservices. Internet of Things. So PaaS can support the broad range of application environments, programming languages, and tools used for IoT deployments. So if you've ever built anything in IoT, things can kind of get all over the place. It allows you to, do that in one application environment, and really get rid of a lot of those inconsistencies. And then business analytics and intelligence. So PaaS tools allow you to analyze your data to find business insights that enable more informed business decisions and predictions. So things like log DNA, and there's a lot of integrated pieces that you get a little bit already with the services that you spin up. And again, if you need more, you can also always get more of what you need, but you get a little bit to see how you like it first. So the most common use case for PaaS is mostly to build, test, deploy, run, and scale applications more rapidly and cost effectively. So for example, there's an Australian-based Ubank. They wanted to innovate by creating a simpler, smarter customer experience without hiring additional development personnel. So they used a platform as a service model, and they were able to create RoboChat. So it's a chatbot that helps their customers complete their online home loan applications. And in just, they were able to roll it out in just 2 months from concept to production. Customers who use Ubank's RoboChat actually have a 15% higher home loan completion rate than those who don't. And Ubank is continuing to use the PaaS, to use platform as a service to pilot new ideas. So if a project doesn't work out, Ubank can quickly scrap it and move on to a new project without wasting money on resources that they're no longer going to need or use. So before we move on to our last model here, so far we've looked at IaaS, CaaS, and PaaS. But you're probably thinking, well, what happened to SaaS, right? So we're focusing as far as our deployment models go, right? So that's what we're focusing on with our IBM Cloud services. We're focusing mainly on containers, infrastructure, platforms, and platform as a service, and serverless. So IaaS, PaaS, and SaaS, software as a service, are the 3 most common models of cloud services. And just so, because you'll probably see these a lot in a lot of different combinations and capacities. So these are the 3 most common models of cloud services. And it's also not uncommon for a company or organization to use all 3 at the same time. However, they can be a little bit confusing. So what is included with each of these. So with IaaS, your cloud provider is offering access to raw computing resources, like we mentioned before, servers, storage, networking. But you would be responsible for the platform and application software. With platform as a service, your provider delivers and manages the entire platform infrastructure. So you're abstracted from the lower level details of the environment, and you use the platform to develop and deploy your applications. So you don't need to worry about the platform infrastructure under the hood. And last but not least, SaaS is software you use via your cloud provider. So just as if it were installed on your local computer. And parts of it may actually be, in fact, be installed in your computer. But SaaS applications reside primarily on your cloud network, and users can store and analyze data and collaborate on projects throughout the application. So our last model we're going to look at is our function as a service. So function as a service is a type of cloud computing service that allows you to execute code in response to events. So eventing without complex infrastructure that's typically associated with building and launching microservice applications. So hosting a software application on the internet typically requires provisioning and managing a virtual or physical server, right? And then you're also managing the operating system and web server hosting processes. But with serverless or function as a service, the physical hardware, virtual machine operating system, and web server software management are all handled automatically by your cloud service provider. So this allows you to focus solely on individual functions in your application code. So, let's go here. So when we're talking about servers, you've probably heard of serverless, functions, Knative, right? So when we're talking about functions as a service and serverless, we're talking about Knative. So when we're talking about Knative, right? So we're talking about this piece right here. So what Knative does is it eliminates the tasks of provisioning and managing servers, like we mentioned before. So this is going to let developers focus on their code without having to worry about setting up complex infrastructure. The benefit is extended further if the entire application components are incorporated from a third party through a backend as a service rather than being written in-house. So Knative serverless environments let you deploy code to a Kubernetes platform, for instance, like Red Hat OpenShift. So with Knative, you create a service by packaging your code as a container, like we looked at earlier, and then you're handing it to the system. What's great about serverless is your code only runs when it needs to. So with Knative, you're starting and stopping instances automatically, only when it's receiving requests. So resources are not going to be consumed unless your code needs to do something. So operations costs can be reduced even more, and you can pay for cloud-based compute time as it's needed instead of like having your application running, right? So it's continuously running and then you're managing your own servers all the time. This is only going to run when it receives a request, when that it needs to respond to. So serverless and functions as a service are often confused with one another, but the truth is that functions as a service is actually a subset of serverless, right? So think of, Kubernetes, right, is a type of, container service. Functions as a service is a subset of serverless. So serverless is focused on any service category, be it compute, storage, database, messaging, API gateways, and billing of servers are invisible to the end user. So function as a service, on the other hand, which is it's maybe the most central technology in serverless architecture. It's focused on the event-driven computing in the application code or containers, right? And it only runs in response to events or requests. So when we're talking about IBM function as a service, what we're referring to is IBM Cloud Functions, IBM Cloudant, and IBM Cloud Code Engine. So not to go too deep into this because we're going to explore some of these options next week, but these pieces that we're talking about with functions as a service. So Code Engine is our offering. It's a fully managed serverless platform. It runs your containerized workloads, including web apps and microservices, event-driven functions, or batch jobs. And what's really cool is Code Engine even builds your container images for you from source code with the Code Engine source to image feature. So what Code Engine can do, so it can create container images from source code. It can access source code in repositories. Remember, we talked about those private and public registries. It can push images to registries, our public and private, whether you want to use Container Registry or Docker Hub or Quay. You can use all of those with Code Engine. It's integrated into IBM Cloud and all IBM Cloud services. So if you want to add chatbots and machine learning and logging and all kinds of cool stuff, you're easily able to do that. Code Engine handles and hides all cluster provisioning. So you're configuring, scaling, and managing servers. It's going to auto scale your workloads up and down, even to 0 when no requests are active. So you're not paying for a stale application, right? You're only going to pay. It's only going to provision an instance when it's receiving requests, so that you're not getting charges when it's not receiving and responding to requests. And it's built on OpenShift Kubernetes, Knative, like we looked at, Istio and Tecton. So you can look at that in that architecture image that I put there. And most important, it keeps your apps and jobs very lightweight and portable. So to just a recap of our functions as a service, pros, right? Our benefits are faster time to market. You can focus on code, not infrastructure. It's less risky adoption of resources. So you're paying only for the resources you use. You can scale up or down automatically. So functions are scaled automatically, independently, and instantaneously when needed, as needed. And when the demand drops, functions as a service automatically scale back down. And you can get all the benefits of robust cloud infrastructures because FaaS offers inherent high availability because it's spread across multiple availability zones per geo. And it can be deployed across any number of regions without incremental costs. So typical use case for functions as a service. So it's good for high volume and parallel workloads. It can also be used to create backend systems or for activities such as data processing, format conversion, encoding, or data aggregation. So it's a good tool for web apps, backends, data stream processing, or to create online chatbots or backends for IoT services, for instance. It can also help you manage and use third-party services. If you're considering Android app development, for example, you can adopt a FaaS approach to keep your costs in check because you're only charged when your app connects to the cloud for a specific function like batch processing, for instance, and costs can be considerably lower than they would using a traditional approach. So we're going to take a look at some business use cases and kind of a hybrid call for code approach. And business use cases used by call for code projects, and Upkar can talk to you a little bit more about those.
Oh, great. Thanks, Jenna. I still hear an echo. I'm on a different computer now, by the way.
Let me mute and see if that makes a difference.
Okay. I do not hear an echo now. I guess we found out what was causing the echo, Jenna.
It was me.
Yeah, no, there's no echo on my side now. Folks in the audience, do you hear an echo now that Jenna is muted? Maybe a quick thumbs up. No echo. Yeah, thanks, Summer. All right, let's keep going then. So Jenna, thank you for that very cool introduction on the different moving parts of cloud and cloud native and everything combined. I definitely learned something today. So I want to give, when it comes to business use cases, right? The term business use cases, it sounds kind of very enterprisey, proprietary. So just so that everybody knows, all of the solutions shown here on the screen and the two solutions that I'll show you in a little bit more detail, they're all open source solutions as part of the Call for Code challenge, right? So these have come up over the years. As you can see on the slide here, we started off in 2018 with a focus on natural disaster, and the themes were around preparedness, mitigation, and recovery of communities and people dealing with natural disasters. And the winning solution was Project OWL. At that year, they created an ad hoc mesh of Internet of Things devices based on LoRa, which is the long range radio protocol. And using this network, people were able to send short messages to first responders, even if the cell network was down. So really nice solution. In 2019, I still work with this team, and I'll show you what their architecture looks like. This is Team Prometeo, and they created a wearable device that firefighters wear with them to their jobs. So these are firefighters fighting wildfires, and the device basically protects firefighters from the effect of these toxic gases and smoke and all of that, right? So it keeps collecting data on the toxicity and creates a nice dashboard for the central command to see what's going on. There's also a little bit of data science or machine learning in the process. Currently, it's more, I would say it's more statistics. They do a whole bunch of time-weighted averages because, as you can imagine, these gases, they don't affect somebody immediately, but over time, the effect of these gases can be very dangerous. So I'll show you what their architecture looks like. And then let me see if I want to showcase another solution here. Well, 2020, as we all know, you know, everything kind of broke, so to speak, in 2020. We started off with a focus on climate change, but then we quickly pivoted to COVID-19. And the winning solution with the COVID-19 theme was SafeQ. And this person made an app, or this team made an app that it's a web app or mobile-friendly web app that doesn't require a login, but it lets you queue up virtually. So when you go to a store, you can sort of sign in to this virtual queue, and you don't have to actually leave your car and get in the store until it's your turn, and you know, they're ready to serve you. So really, really neat idea. I think they used serverless function, which is ideal for something like this, where you know you're processing, or you don't know how many people will show up, how long that queue is going to be. So your demand varies over time, and you don't have an idea of when it's going to go up or go down. So again, function as a service, be that Code Engine, IBM OpenWhisk, or sorry, Apache OpenWhisk or IBM Cloud Functions are good, ideal solutions in that case. We also had another team called Quireless, and Quireless built an app using AI to perfectly sync up different recordings. And so this was, again, at the time of COVID, when people were stuck in their houses and you know, they couldn't get together to create a performance. And so they used AI and machine learning to sync up the different instruments and create music, or people were able to still get together over the internet and create music. And they were also heavy users of Cloud Functions. The whole eventing side of Cloud Functions is very handy, right? So when an audio file comes in, you may kick off processing of some sort, right? And that looking or keeping an eye out for that event, it's Cloud Functions made that sort of thing easy to do. When we look at Code Engine next week, or sorry, not next week, in our next session, when we look at Code Engine, you'll see that Code Engine also has this concept of eventing. And so currently the two kinds of events you can look out for in Code Engine are ping-based events. So you can subscribe to a ping, which basically means it's a cron job. So you want to do something a certain time regularly, you can do that. And the second one is looking at Cloud Object Storage. So you have a storage option where new data comes in. You may want to kick off a batch process job, right? That's another one we'll look at later. So again, in 2020, the second thing that we did was IBMers got together. You know, IBMers who were frustrated by what was going on in the world, especially in the United States, based on you know, racism and discrimination. They decided to get together and use technology to sort of channel their frustration and fight against systematic racism. And that's one of the other solutions. I'll show you how they architected their solution based on the different components we've looked at today. Jenna, if you could move on to the next slide, please. Ooh, maybe the other way. Thank you. All right, so here's Prometeo. I actually already told you what the solution is. So they use IoT, Internet of Things. This is the first version of the product. You can see this firefighter in Barcelona. He's wearing a device, the green color device on his vest. And now we are in iteration 3. We just finished field testing for iteration 3. So iteration 4 coming up, the device looks a lot different. We are also making the device a lot more rugged, right? As you can imagine, the temperatures reach very high. Or their surroundings it reaches a really high temperature, and so you want the device not to melt. That's one simple thing we're trying to improve. And there are other things as well. For example, where does it get its charge for, battery life, what happens to the device is offline, how does it actually connect to the internet, to IoT, how does it send data, things like that. They use Kubernetes to deploy a lot of their services. And if we move on to the next slide, Jenna, I can talk to the architecture. Thank you. So, and it's loading on my side. Here we go. So it takes a couple of seconds for the slide to settle down, and you can read the text here. But basically, on the left are the firefighters. They are carrying they're wearing their Prometeo devices, shown here in the orange color. They also carry with them a watch and a smartphone, and that's how the device talks to the IoT platform. All right, so firefighter first goes in, they use this service called App ID to authenticate to the mobile device. So they're allowed to use the application. Once that happened, then they pair their wearable device with their mobile phone using Bluetooth. And once that pairing is successful, now the device is able to send data through the phone to the Internet of Things, which is the next big block in the middle. Internet of Things, it provides a service to manage these IoT devices, as well as provide a sort of a message broker or a message bus where you can send messages on certain topics, and then other people can listen to those messages. There's a whole other part of IoT service that we didn't use in this project, but you can do things like analysis, backup storage, and things like that. So once the data comes in, you can see a couple of different services deployed in Kubernetes cluster. So in this case, we deployed if you look at number 4, there's a Node.js service which is listening to the IoT platform. As soon as data comes in, it picks up the data and it does a couple of things with it. Number 5, it sends the data to MariaDB database. MariaDB is a relational SQL database. We deployed that as a pod or as a deployment in our Kubernetes cluster. So there's a PVC underlying or underneath the deployment where the data is stored at persistent volume. And then that's how we store our long-term historical data. Number 6, you can see the client also sends some data to a WebSocket server. WebSocket server in Kubernetes is pretty interesting. And what happens is the WebSocket server, the dashboard is listening to the WebSocket server, connected to the WebSocket server, so it knows when data is coming in, and it's going to show a whole bunch of graphs and line charts and gauges, different widgets to show you the data coming in live. And we also have a service in Python written, which is called rules decision, and that service, it wakes up every minute, and I think that one uses just a Python cron scheduler. So the deployment is running all the time, and then the rules decision service is not sleeping, it's just there. And every minute the Python job kicks in and calculates the time weighted averages. So this would be a very good use case of using something like Knative or using something like Code Engine, where this rules decision service could then subscribe to a ping event and do its job every minute, right? So, and then finally, the command center or the central control can look at the dashboard to monitor the health of firefighters over time. So this is one example. One missing piece here is we do have a simulator. So when we were testing, we quickly realized, these hardware devices have to be connected and sending data. And how do you produce those toxic gases, right? If you're not out in the field, it's hard to simulate that, or it's hard to produce that. We actually had one of our team members in Barcelona burning things in his kitchen, plastic, to produce those gases, and that, obviously that can get dangerous. So we built a simulator. It's a cloud function that basically just simulates a device, pretends to be a device, and connects to the IoT platform and sends information to IoT platform. And then I created a code engine version of that simulator. So the one thing I do want to notice is, we talked about IaaS, PaaS, and container as a service, function as a service. In this case, you can see we are using both Kubernetes in a platform as a service manner, as well as Cloud Functions as a function as a service, right? So a lot of times you have to make that choice. Like there, in this case, it worked out that the different pieces aligned well to the functionality that we needed. So with the simulator, that's all it does. Every minute sends a message, right? So function as a service kind of fit that description really well. And the other services need to be always up and running. So we decided to go with Kubernetes. So again, it is sort of a choice, but in the same application, you can have different pieces using the different kinds of platform that Jenna went through. So yeah, so this is, so there's a question, MQTT is a Zigbee protocol or not? I am not sure what that, I know MQTT by itself is a protocol. I'm not 100% sure if it's, or what a Zigbee protocol is. You might have to Google that one, unless Jenna knows. All right, so Jenna, do you want to move forward? Thank you. All right, so the next one I want to talk quickly about, this is a different application. It's called Legit Info. So Legit Info shows you different legislation. So right, that's one of our call for code for racial justice projects. Again, completely open source, and it shows you the different legislation based on the area you will live in and what you're interested in. So for example, I could say, hey, I live in California. I'm interested in all the legislation and the laws that were passed that impact healthcare, or that impact food, or that impact something else, right? That's what I'm interested in. So it'll go and pull all of this legislation from the different APIs and sites and show it to me, right? Now, currently, it's the data that is in there is US based, but it could be expanded to other countries as well. There, of course, will have to be changes to how it's grabbing the data and things like that. So this diagram here is just showing the three different stages in development. So on the stage one is using everything in the local laptop. So except Watson NLU, which is the natural language understanding piece. And I'll show you in the diagram how these things relate. But I'm using an SQLite database, which is just temporary for development purposes. The app is built in Django, and I come in through my browser. Then in stage two, we move some of those parts to the cloud. So instead of using SQLite 3, we use Postgres on the cloud, IBM Cloud. Instead of using a local file system, we use IBM Cloud Object Storage to store the legislation, right? And in stage 3, we actually move the Python application over to the cloud as well. So the stage 3, Jenna, if you move to the next slide, it shows you what stage 3 looks like in a code engine world, right? So we actually started off this application deployed to Cloud Foundry. So somebody, I think Amar, you were mentioning Pivotal Cloud Foundry. So IBM offers that as a solution on IBM Cloud. It's called IBM Cloud Foundry. And we had this whole application built on that. We quickly realized that there are a couple of side jobs or batch jobs that we need to create. And Cloud Foundry has this concept right off, I think it's called a sidecar, if I'm not mistaken. They have that concept. We looked into it. But by that time, Code Engine came along, and Code Engine is very nice. It's got this clean, two types of assets you can build on Code Engine. One is an application, one is a job. And so that really fit our architecture really well. Amar, yes, so HDL also has the concept of sidecar, correct? So in this case, you can see a user comes in, there's a legit info application, which is a Django application, is sitting in Code Engine as an app, and it talks to the Postgres database and gathers information from there. In the background, we have 3 jobs. So get data set, extract file, and analyze text. All these are, again, Django custom commands, and they live as jobs in Code Engine. So what that means is they are a one-time thing. They wake up, they do their job, and then they go back to sleep, right? Until next time they're woken up by, in this case, it's running with time. So they wake up at a certain time, do their job, and go back to sleep. And their job basically, get data set, works with this thing called Legiscan API. It grabs all of the legislation from there and stores it into Cloud Object Storage. Then extract file, again, looks at Cloud Object Storage, extracts the legislation, the actual text. And then the analyzed text uses natural language understanding to figure out if the legislation is should be categorized as healthcare or environment or education or whatever. So that's the NLU's job. And so in this case, you can see a Code Engine pretty much fit really well in this case with the one application, 3 jobs. And then it's talking to certain pieces in the cloud as well. So those 2 hopefully give you a little bit of flavor. What I'm going to do is, I think Jenna, this was I'm going to pass it back to you. Yeah.
Okay. Yeah.
All right. So Just before I pass it back to you, I'm going to put all the links in the chat. And folks, sorry for the echo again. We'll go and mute them.
Okay, cool. Also, it looks like the architecture got cut off a little bit on the bottom, so I just re-added it to the slide. So if you look at the slides, the full image will be there. It got chopped off a little, but I just fixed it. So if you're still with us and you're still hanging in there and your brain isn't melting too much from too much of an overload, congratulations. So we've completed part 1 of our journey to the cloud, IBM Cloud Deployment 4 Ways, where we took a look at 4 different cloud deployment models and IBM's offerings and services associated with each one, and what are the pros of using each one, so you can maybe get an idea of what's going to be the best option for you. I just posted a feedback survey. It is a very quick survey. It's 2 questions. You don't have to enter your name or any of your information. It's an anonymous survey, so feel free to let us know, how we can improve this and make this better. Maybe some topics you'd like to see in the future. I also have a link here to the hands-on portion of this content. So next week is the accompanying Journey to the Cloud, IBM Cloud Deployment 4 Ways hands-on workshop. So it'll be next Wednesday, same time, same place. And the link to register and access the next week's event, I've posted the Crowdcast link. That's where we will be joining for next week. I would also like to share with all of you, I think Upkar shared the call for code workspace a little earlier. Here's the links here. So again, this is in the chat, so if you click on it, it'll open up in a new window for you. So again, this is next Wednesday, same time. So this is we'll get our hands dirty and get hands-on with each of these deployment models, so you can get a feel for, what it's like, what's involved with each deployment model. I have all of the resources and everything for you here as well. One thing I want to share in the chat is, if you would like to stay connected with us, check out any of our other content, feel free to connect with us on LinkedIn. You can check out more content on YouTube. I have a YouTube channel. I also have our IBM Developer YouTube channel here. So feel free to stay connected with us. Upkar, I was going to repost where did it go? Aha. Here it is. I'm going to repost this. This is the call for code Slack workspace. There you go. So if you're interested in learning more about call for code, you have any questions, you want to get connected with any of us, you can contact either one of us or any of the other IBMers in the Slack workspace. Get connected with us there. Thanks, Mar. I know it can be a lot, but I want to make sure that you're exposed to all these things. So as you do them more, as you hear them more, you absorb a little bit more and more information as you see these things and learn a little bit more each time about them. Again, I have all of the event resources here for you at the end as well. Again, everything's in the slides. The cloud slides are, the link to the slides is at the beginning of the chat. Feel free to connect with us on any of our socials, IBM Developers social. And again, feel free to, I'm at Ritten on all social. You can check out my link tree. So if you're working on any call for code stuff, you'll see my link tree in the Slack workspace as well. If you need to book some time with me, get some help with your application. Yeah, so that's all we have for you today. Thank you all so much for coming. Thank you so much, Upkar. If you have any questions, feel free to post in the chat. Give you a little bit of time to do that. And for the rest of you, we will see you next week. So I'll see you next Wednesday. Thanks so much for coming.
Thank you.
Thank you.